Hello and welcome to this video tutorial on how Tally and Weld mapping are used when surveying the pipeline. In the How to Create a Pipeline Tally video, we learned how to create a pipeline tally. The next step is to create a joint map which records the weld ID and the relationship between the weld and the joints either side of the weld. When you come to measure the weld, you will only need to enter the weld ID to automatically have the joint IDs and attributes for both joints associated with your measurement. Pipelines uses the weld ID to find the joint ahead and behind IDs from the joint map, and then uses the joint IDs to get the joint attributes from the tally. Joint mapping with pipelines also allows you to record loose ends and bends as well as welds, but weld mapping is the key workflow we are focusing on in this demonstration. Joint mapping is accessed from the tally menu. Ensure the method is set to welds. When you go into joint mapping, all fields are empty. Tap Next to jump to the last weld ID recorded in the weld map. Alternatively, you could tap the arrow on the weld ID field and select Next Weld ID to find the next available weld ID. Weld ID 5 is displayed. Note the ahead ID ends in 6 and the behind ID ends in 5. Key in 6, the next weld ID. As I move off the weld ID field, note how the ahead and behind IDs are updated automatically. The new joint ahead ID defaults to the next record in the tally file. The behind ID is based on the previous joint ahead. How the defaults behave depends on two things: the direction arrow displayed between the joint IDs and how you configure options. Make sure the direction button matches the downstream or upstream direction you are mapping the welds. Tap the button to change the direction. The direction button controls whether the joint ahead becomes the joint behind and vice versa as you move along the pipeline. Tap Options. If the order of joints in the tally matches the order on the ground, it can be useful to enable the option to default to the next joint ID from the tally. If the weld ID is increment or decrement, it can be useful to set the weld ID to default appropriately, but if they don't, then you're probably better off with no default weld ID. Tap Accept to close options. Note how when the cursor is on the weld ID field, Next and Previous are available, allowing you to scroll through existing weld mappings. When the cursor is on the joint fields, the Details button is available to check and, if necessary, change the joint details. Within Details, Next and Previous allow you to switch between the details of the two joints. Tap Record Position to record a position. Tap Add to add new weld mappings to the weld map. Tap Save to save the changes to disk. Tap Update to update any changes to an existing weld map. Tap the Shift arrow to access Rename and Delete. That is all there is to do for weld mapping. We'll now demonstrate how to measure a natural ground shot and then a weld, show how the joint attributes are attached and cover is computed. Select Measure Pipeline Points. Measure and store a ground shot near the weld about to be measured. We've configured the system to compute cover from the last measurement. See the How to Compute Cover video for more information about the various methods for computing cover. Now measure the weld. In the code field, enter the weld code and tap Measure. When you tap Store, the Compute Pipe Cover screen is displayed. Here we can see the name of the last measured point, its code and distance away. We needed a minimum of 1.5 metres of cover, which we have. Tap Store to display the attribute screen. Pipelines will default the next weld or extra ID after searching the job for the last used weld ID. Confirm the weld ID. Note the joint ahead and joint behind IDs are automatically populated from the weld map. Tap Details to check the details of the joint IDs that were pulled from the tally file and will now be stored with the point. Modify the joint details if required, complete any additional attributes and store the measurement. When using a weld map, Pipelines also checks that the distance to the last measured weld matches the joint length recorded in the tally file. We failed the length check because my measurements were not exact on the welds. Measuring welds and recording all information about the weld in the joint ahead and joint behind and storing this in the job file with position is as easy as this. Select your weld code, enter the weld or X-ray ID and have the joint IDs referenced in the weld map file used to pull the joint details from the tally file. Because all the information is now recorded in one place in the pipeline's job, custom reports and export formats can be easily created directly from the controller or from the jobs using the ASCII file generator utility. There is no longer any need to synchronize data from multiple files back in the office later. This completes our video explaining how to use a joint map when measuring a weld. Please see the link displayed for more information about Trimble Access pipelines. Thank you.